Hey guys, Dr. Brown here, and we're continuing with understanding volume as a function of rotating an area, some bound area around an axis. So we've taken this same function where we have y equals square root of x, y equals 0, x equals 3, and that's the area that's bound by those three lines. And now today, before we've rotated in one video around x, another video we rotated around y, and then the last video we rotated around x equals 3. Now we're going to take that and rotate it around x equals 6. Whoa, let's get after it. Okay, we know the two methods. We've studied the shell method and the disk method. I'll just start with shell. So shell says set up my dx or dy parallel to the axis of rotation. So here we have this parallel to x equals 6. And then it says to do two things. What is the distance from the center of that differential that we've set up, in this case dx? How far is that from the axis of rotation? Well, that would be 6 minus x. So this full distance minus that distance, so that's 6 minus x. That would give me p of x. Okay, now what is the height of that box? Okay, so that is f of x, or, well, they call it the height with respect to x, so that's square root x. So now let's determine our volume. That is 2 pi, the integral from 0 to 3. That's the area that's being rotated. Okay, so 0 to 3. Now let me stop the video. I've got a buzzing noise in the background. Hang on just a moment. Well, the buzzing noise outside, I thought it was my fan about to play out, which is critical, okay, in this heat. All right, so now we have the volume is 2 pi, the integral from 0 to 3 of p of x, h of x, dx. So that's 2 pi, the integral from 0 to 3 of 6 minus x times the h of x, which was the square root of x, x to the 1/2, dx. Okay, so let's distribute that to the inside. 6 times x to the 1/2 is 6x to the 1/2 minus x times x to the 1/2, so x is x to the first, that's x to the 2 over 2 plus 1 over 2, that's x to the 3/2. All of that's dx. So now let's integrate. Okay, so we have the constant 6 x to the 3/2 divided by 2/3, or divided by 3/2, so I'm multiplying by 2/3, minus x to the 5/2, so that's x to the 3/2 plus 1, which is 2 over 2. So x to the 5/2 divided by 5/2 are multiplied by 2/5. And we're taking that from x equals 0 to 3. Okay, so now let's work through some of the math here. 6 times 2 is 12. 12 divided by 3 is 4. 4x, which is 3 cubed, and the square root of that. I'm going to take that as 3 to the square root of 3 cubed. That's how I'm going to look at that. So I have square root of 3 times square root of 3 times square root of 3, which is 3 times square root 3. So now 4 times 3 is 12, so I have 12 square root 3, okay, minus, and I should do this, this helps me not forget about that second term. We've had so many problems where 0 is the beginning number, or you're integrating from 0 to something. And the other day, one of these had maybe a 2, and I just left it off altogether. So I would encourage you put 2 sets of parentheses here so you know you have some more work to do. That's one of my kryptonites. Bad for me. Okay, I have 2/5 x 3, the same scenario. I have x to the 1/2 raised to the 5th in this case. So I have square root of 3 raised to the 5th. So this one's 3 times square root 3. So 9 square root 3. 9 times 2 is 18. So 18 square root 3 over 5. Minus, my parentheses, I have to do something there. What to do? Okay, 0, put the 0 back in and it does come to 0. So no harm, no foul. All right, 2 pi times, well, I need a common denominator. So I need to multiply this by 1, which is 5 over 5. Okay, so 5 over 5, 5 times 12 is 60. 60 square root 3 minus 18 square root 3 all over 5. So my volume equals 2 pi times 60 minus 18, 60 minus 20 would be 40, so it's 42. 42 square root 3 over 5. And that equals 2 times 42 is 84. 84 pi square root 3 over 5. So that's my volume using the shell method. So let's take shell equals 84 pi square root 3 over 5. All right. I'm going to pause and clean up the board and change my marker. I'll be right back. Okay, I'm back. All right, now the next method is the disk method. In the disk, they want us to determine volume by looking at the outer radius squared minus the inner radius squared. So it's pi times the integral from C to D in this case of the outer radius squared minus the inner radius squared, in this case dy. So this is r of y, big R of y, little r of y. So they also want you to set up the differential perpendicular to the axis of rotation. So that tells me that I'm going to be integrating on y. Well, when x is 3, square root of 3 is y. So I know my y value at this point of intersection is square root 3. All right, what's my outer radius? What's big R? Well, it's going to be that distance right there. Well, how do I calculate that? If I use an x here, wherever this point is, that would be x. So 6 minus x. But what is x? If y equals square root x, if I square both sides, y squared equals x. So this would be 6 minus y squared. So my volume is pi times the integral from 0 to square root 3 of 6 minus x, or 6 minus y squared. So that's r of y squared. Minus, what's the inner radius? 6 minus 3, so it's just 3. 3 squared is 9. I guess I should set it up like this. 3 squared dy. All right, so what is 6 minus y squared? All right, that's 36 minus 6y squared minus 6y squared. So that's 36 minus 12y squared plus y to the fourth minus 3 squared, which is 9. And I'm integrating all of that from 0 to square root 3 multiplied times pi, integrating with respect to y. Okay, 36 minus 10 would be 26 plus 1 is 27. So integrating from 0 to square root 3 of 27 minus 12y squared plus y to the fourth dy. All right, let's integrate. All right, we can do it. All right, we're getting close. 27y minus 12y cubed over 3 plus y to the fifth over 5. And that's integrated from 0 to square root of 3. So 20 pi times 27 square root 3 minus 12 over 3 is 4. Now I've got square root of 3 cubed, which is 3 square root 3. We did that earlier. 3 square root 3 times 4 is 12 square root 3 plus square root 3 to the fifth. I forgot what that was. I think it's 9 square root 3. So I know this may look silly writing it down like this, but I just want you guys to understand how that works. Square root of 3 times square root of 3 is 3. Same here. So 3 times 3 is 9. 9 square root 3 over 5. Oh, I didn't do the 2 brackets here. Should have. All right, so if I plug in 0 in, all of those wipe out. There's 0. All right, can we simplify something? Well, we've got a, need to get a common denominator here. 27 times 5, 35, 3, 10, 135. So I have pi 135 square root 3, and all this is going to be over 5, minus 60 square root 3 plus 9 square root 3. So 135 minus 65, 675. So I've got 75 square root 3 plus 9 gives me 84. 84 pi square root 3 over 5. 84 square root 3 over 5. Hey, so that's what my volume equals. That looks like that's 8 to the 4th power. That's 4 problems now we've worked using, well, it's the same functions, but we've rotated around X in part A, or the first video on volume. Part B, we rotated around the y-axis. Part C, we rotated around X equals 3, and now this is part D. We've rotated around X equals 6. I would encourage you, whatever the problem is you have, practice rotating that around different different lines, different areas, and get familiar with which method is the best to use. Like in this case, it seemed to be a little bit more work with this one than it did with the disc than it did the shell. But in either case, it all worked out. Okay, why are we doing this? Together, we're trying to build a better tomorrow and do that through math. That's all for now, and we'll talk to you next time. Keep studying.